There's something we all know about triangles. Hopefully we know it. Here it is. It's that all angles, all interior angles, that means angles on the insides of the triangle, add up, or in other words, sum to 180 degrees. And that's going to get a lot of mileage in this unit on triangles, because when you're missing one of the angles, you can look at the other two and say, well, I know all three of these have to add up to 180. You can always rely on that. So what I'm going to do is take a look at this similarity statement up here, okay, this guy, and we're going to try to grab what information we can from that, because you know if triangles are similar, what that means is they have equal angles. They may be rotated around so they don't appear like they're in the same place, but those angles have to be equal. And the first thing I'm going to do is look at angle F right here. See that angle F? This guy? It says it's similar to angle A. Now, if those are the same angle, then that means I'm just going to write 31 degrees over here for angle A. You can put that in for your answer for F if you like. But now knowing that, look what we have on the triangle on the left side. We have two angles. So let's use those. Let's say 31 degrees, that's A, plus 96 degrees, that's D, plus whatever this G thing is, equals 180. Okay, so next we're just going to do the old familiar subtraction steps. So we're saying minus 31 from both sides, and that'll give us, let's see, what do we get there? That's going to give us 96 plus G equals 149, looks like it. Okay, and now of course we're going to do another minus sign. We're going to say minus 96, and you don't have to do it in two steps. If you wanted, you could have added 31 and 96 together first. Doesn't really matter. We're going to get G, angle G equals, looks like 53 degrees. Okay, so let's label that on our graph, or our chart, 53 degrees. And according to my plot, what is that equal to? Well, let's see. G is right here, and it says that's similar to angle C. So here we are, angle C right there must be 53 degrees. And the only thing missing is P, so let's go back to our chart and see where P is. P is right here in the middle, it's sort of squeezed in there, and that is similar to D. So that must be 96 degrees. And that'll wrap up this problem. See, it's some bit of knowing how to compare angles on triangles when they're similar but twisted around. But a lot of the legwork was that 180 degree summation.